This is lecture 6.1 for Math 65. First, we're going to talk about the greatest common factor. In chapter 5, we multiplied polynomials. We distributed 2x into the trinomial 3x squared plus x minus 3 and got 6x cubed. That's 2x times 3x squared. And then we got 2x squared, so that's 2x times x. And then minus 6x we got from the 2x times negative 3. Whereas in chapter 6, we are going to be factoring polynomials, which is the reverse of what we just did. So we are going to turn 6x cubed plus 2x squared minus 6x into 2x times 3x squared plus x minus 3. So this is going to be the main thrust of what we're learning in chapter 6, and this is the reversing the distributive property. In other words, when we factor, we are breaking down the polynomial into multiplication. Let's look at what we did when we were doing prime factorizations back in, I think that was chapter 2. We would take a number like 24. And we would factor it. And this is what we're doing with polynomials now, is factoring. But in just a single number, we were looking for those things that when multiplied together would give us 24. So we had things like 2 times 12. And then we broke the 12 down into 2 times 6 and 2 times 3. So we came up with a prime factorization of 2 times 2 times 2 times 3. All right, so this was prime factored. We factored it all the way down. And that's more or less what we're going to be working for with these expressions, these quadratics and cubics and such. We're going to be breaking them back down into their component pieces. Okay, so greatest common factor. The greatest common factor is the largest number that divides all numbers being factored evenly. Okay, so let's look at the definition, right? What this word is, greatest. So largest, it's the largest number. Largest. Common divides all numbers. So it's common to all the numbers that we're factoring. And then a factor is, these are factors. Okay, so it's the greatest common factor is the largest number common as a factor of all the numbers. Let's begin with whole numbers. What is the greatest common factor of 35 and 28? Well, 35 is 5 times 7. 28 is 4 times 7. So the greatest common factor is 7. It's a common factor. It's a factor to both terms, and it's the largest factor. Okay, so that's 7. Practice finding the GCF, greatest common factor, of the following numbers. Okay, so we have 12 and 16. Well, let's see. 12 is 3 times 4, and 16 is 4 times 4. So our greatest common factor is 4. I can't get anything else out of the 3 and the... Sorry, let me do some highlighting so you can see what I'm talking about. The 3 and this 4 have nothing in common. So I can't reduce those. And the other two are just the largest numbers I have that are going to be equal to or factors of these two numbers. So the greatest common factor is 4. Okay, 80 and 96. Well, let's see. 80 is 8 times 10. 96 is 8 times 12. Well, 10 and 12 both have 2's. So that means 80 is 16 times 5. And 96 is 16 times, 12 divided by 2 is 6. All right, so now you can see that 16 is my greatest common factor, because 5 and 6 have no common factors. All right, let's move on. 75 and 45. Well, 45 is 3 times 15, and I know that 15 goes into 75. It's 5 times 15. 3 and 5 have no common factors, so my greatest common factor is going to be this 15. So that's my greatest common factor. To find the greatest common factor of two large numbers, prime factor each. Determine the prime factors they have in common, and the product of these prime factors is your greatest common factor. To find the greatest common factor of a variable, consider the following. Well, we have x cubed is 3x's, and x to the 5th is 5x's. What do they have in common? Well, 3x's, 3x's. That's my greatest common factor right there. It's going to be x cubed. Note it's the smallest exponent. In other words, the GCF of two variables is the smallest exponent. To find the greatest common factor of variable terms, first, find the greatest common factor of the coefficients. Remember, one is always implied if a coefficient is not present. Find the greatest common factor of the variables that the terms share. Which is the variable with the smallest exponent? Okay, so now let's look at these here. Notice, okay, first we're finding the greatest common factor of our two constants. So we have 8 and 4. Well, 8 is 2 times 4, so our greatest common factor is going to have a 4 in it, because I have 1 times 4. Okay, now we're going to look at our two variables. I have x to the 8 and x to the 6. Well, there is 6 x's inside the x to the 8. So x to the 6 is our greatest common factor. Okay, so our greatest common factor is 4x to the 6th. Now let's look at number 2, 16x squared y and 36x cubed y cubed. All right, so we're going to break this down. 16 is 2 times 8, or 4 times 4. Okay, we'll go 2 times 8, which is 2 times 4, which is 2 times 2. And then we have 2 x's and a y. 36 is 2 times 2, which is 4, times 3, which is 9. I have 3 x's and 3 y's. So, what do I have in common? Well, I have a 2 and a 2, a 2 and a 2. No more 2's. The top one has no 3's. All right, now I have an x and an x and an x. And then I have a y and a y. So my greatest common factor is going to be 2 times 2, which is 4, x times x, x squared, and a single y. So that would be my greatest common factor. All right, let's look at number 3 here. 3 and 5. We have no numbers that are in common. Again, if I factored these, I'm going to have 3 and then 3 x's and 1 y. 5 and 4 z's. Now, when I look at this, hopefully you're seeing that there's nothing in common. The first term has no z, has no 5. The second term has no 3, no x's, and no y's. So there is nothing in common with these two numbers. Okay, sorry. All right. All right, factoring a monomial out of it or from a polynomial. So we're going to look at it and determine the greatest common factor between the two numbers, and that's what we factor out. Okay, so we have 3x squared plus 6x. Well, they both have, as you can see, they both have a 3x inside of them. So we can factor that 3x out and pull it all the way over and multiply it times what was left. What was left was the x and the 2. So that's what's left. That's what we have. Now, we can check this by distribution. 3x times x is 3x squared. 3x times 2 is 6x. And sure enough, that's what I started out with. So that means I was right, that was the greatest common factor. Okay, so now we're going to practice factoring out the greatest common factor. All right, when I look at this, I have 15, which is 5 times 3. 12 has a 3 but no 5. 27 has a 3. So this becomes 4 times 3 and 3 times 9. So we're going to be pulling out a 3. And then what's going to be left behind, I'm going to have a 5 something something minus a 4 something something minus a, plus 9 something something. Okay, so that's what I've got so far with just the constants. Now I have an x to the 5th, an x to the 4th, and an x third. So the smallest is x to the 3rd, so I do have an x to the 3rd I can factor out. So what's left behind? This 5. 5 minus 3 is 2. So I have an x squared. 4 minus 3 is 1, so I have an x. And I've pulled out the entire x cubed. So this is what I have. All right, so let's double check this. I multiply these. I have 15x to the 5th minus, and I multiply these two, 12x to the 4th plus, and when I multiply the last one times 9, I have 27x cubed. And I look back over here. All right, I'm going to erase this so you can see it a little better. Sure enough, 15x to the 5th minus 12x to the 4th plus 27x cubed. So there we have it. 5a minus 15. Well, notice both of them are negative, so I can factor out a negative. They both have a 5, but they do not both have a's. So I'm left with an a. Now this is a plus because I pulled out the negative. 15 is 5 times 3, so the 3 is what's left behind. And sure enough, I'd have minus 5a minus 15 when I distributed this in. Okay, 3x to the 4th minus y to the 5th. They don't have anything in common. The first term has no y. The second term has no 3's nor x's. Nothing in common. You cannot factor. Okay, number 4. I can factor out a negative and a 2. And that's going to leave me with a plus 2 where the 4 is. X squared and x to the 3rd. Sorry, I couldn't see the 2. X squared and x to the 3rd. So the x squared is what I can get out. Well, notice I'm leaving behind an x here, but I have a problem. if I reconstructed this, if I checked this by multiplying negative 2x squared to the 2x, all I'm going to get is the negative 4x cubed. I need a placeholder right here to get this term when I multiply it back out again. Now, if I multiply it, I'm going to end up with the right answer. All right, how would you check these? Well, we've been talking about that all along. We would check them by redoing the multiplication, doing the distribution. All right, so here I'm not taking out a negative because they both aren't negative. I am going to take out a 6, so that's going to leave me with a negative there, and a 2, because 2 times 6 is 12. The x's, I have only a single x, right? That's right there. So I'm going to leave an x in the first term because it was x squared. Now I can pull out the y. They both have only one y, so it's completely pulled out. So my final answer, now if I multiply this to check it, I'm going to have a minus 6x squared, and that line was just to separate the two. This is my check. Minus 6x squared y. Now when I multiply over here, I get a positive 12xy. And sure enough, that's what I had to begin with. All right, for number 6. Looks like they all have a 3. Looks like they all have a 9. So I can pull out a 9. I'm going to be left behind. I'll be leaving behind for the 27, a 3. For the 18, a 2. And for the 45, a 5. Okay, that's supposed to be a minus. All right, now I have an x squared, an x, and an x squared. So I can pull out the x. The smallest number, remember. So I'm pulling out that x. And since that's the smallest, I can only pull out of x everything else. So x squared without one of the x's is just x. It completely disappears from the second term. And the third term, having an x squared, is reduced to an x. Now I have a y cubed, a y squared, and a y. The only thing I can pull out is the y. It's always the smallest term. And there it is. Okay, so when I pull a y out of the y cubed, I have y squared. When I pull a y out of the y squared, I have just y. And it completely disappears from the last term. So there, that would be my answer. Okay. Now notice this is an interesting problem. I have 2 terms here. 1, 2, separated by a plus sign. So I'm looking for what they have in common. The x squared and the 3 are not in common, but they do have the x plus 5 in common. So I can actually factor that out. I can pull out, and oops, I don't want to be writing in pale green. Okay, so I can pull out the x plus 5. What is left is the x squared and the plus 3. And there we have the factor. Okay. The second one, again, we have, notice, x minus 6 in common. The 2x and the minus 7 are not. So I can pull out the x minus 6 and leaving behind the 2x minus 7. And again, I have factored form. I can check this by distribution. I'm going to take the 2x minus 6 and multiply it by 2x. That's what that is. And then again, the x minus 6 and multiply it times negative 7. That's that term. And I'm back to my original. Okay, so 9. All right, I'm going to pull out the x cubed plus 4. Okay, So I have x cubed plus 4, close parenthesis. And what is left behind is the 5xy. And then minus, when I pull the whole term out, I have to leave behind a 1 as a placeholder, so I know that I have to put it back into the final answer. Okay, and that is not the end. Okay. We move on. Here's page 4. Factoring by grouping. We do this when we have 4 terms, or we can sometimes split 2 terms to see what they get. So notice they have our x terms split up. So what we're going to do is we put parentheses around this. I can pull an x out of both of those. So this becomes x plus 2. I apologize for that horrible writing. My little thing I used to hold my hand off the tablet just fell off. Okay. I pull x out of the x squared, and I get x. I pull x out of the 2x, and I have just 2. Now on the next one, I pull a 6 out. I'm left with x and a 2 again. So notice I now have the x plus 2 I can pull out. And what's left behind is x plus 6. Okay, whoops. All right, we have 9x squared plus 6x. Again, I'm going to pair them off. The first two, they both have a 3, and they both have an x. So I'm leaving behind a 3x plus 2. In the second term, they both have a 5. And that again will leave me with 3x plus 2. I factor out the 3x plus 2, and I leave behind 3x plus 5. And that's my factored form. Now again, you can check this. Don't simplify, and you'll get the exact same thing as B. Okay, 28x squared and 8x. Well, they both have a 4. Actually, they both have a 4x. So now I have 7x plus 2. If I pull out a 3, I have 7x plus 2. All right, so now I can pull out the 7x plus 2, and I'm left behind a 4x plus 3. And again, that's my factored form. All right, now we have 5x squared and 10x. So I have 5x, leaving behind x and a 2. Here I'm going to pull out a 3, and I'm leaving behind x plus 2. So I can factor out the x plus 2, leaving behind 5x plus 3. All right. I pull out an x. I have x plus 7. And notice I have just an x plus 7. All right, so when I factor out the x plus 7, I have to be careful and leave that placeholder there of a 1 so that I know I have a term there. I pull out an x. I have x plus 3. And I have nothing to pull out. I still have an x plus 3. So when I factor out the x plus 3, I have an x plus. Remember, I have to leave the 1 behind as a placeholder. Okay. This gets a little dicey on this one. They both have a 4x. That's going to leave me 3x minus the placeholder of 1. But now I have a minus. The problem with that is you have to think of pulling out a -1. So my 3x become positive, but my 1 becomes negative. If that didn't work that way, you wouldn't be able to factor anything out of this one. So now I factor out the 3x minus 1 and leaving behind a 4x minus 1. All right, last page. Oh, sorry, H was my top. Okay, so now I have, okay, this first one, 3x, 5x minus 1. Oops. There we go. Minus, now remember we have to flip all our signs because of that minus out front. Now I can factor out a 5x minus 1. And it leaves behind 3x minus the placeholder of 1. All right, on this one, I pull out a 5x, x minus 2. All right, these two, they both have 15 in them. So I can pull out a 15, and I'm leaving behind x minus 2. Yay, means I can factor it. X minus 2. What was left behind was a 5x plus 15. Okay, got to take that negative into consideration. Here I can pull out a 6x. Leaves me with x plus 5. And minus 18. Minus, I can pull out the full 18. If I had pulled out 9, it would have been a 10, so 18 means a 5. So I can pull out the x plus 5, and that leaves behind 6x minus 18. All right, now I pull out an x plus a, pull out a b, x plus a. So now I pull out the x plus a, and I have x plus b left behind. Oh, that's not a 1, that's an L. Okay. Now, they both have a 2 and an x. So this is 5x minus 6y. Now, I can pull out a 7 and a y. When I pull out 7y, I end up with 5x minus 6y. Sure enough, those two are the same, so I can pull them out, 5x minus 6y. And I have 2x plus 7y. And that's my final answer. And I believe we are done. Thank you.